Exercise 8b on simple harmonic motion. Part A, describe the motion of the particles. You know it's going to be simple harmonic. Just going back to the definition, the acceleration, so that is d2x by dt squared, is proportional to the displacement from air. So look, it is proportional to the displacement, so we have simple harmonic motion. From now on, it's just the stuff we were doing in exercise in chapter 7 there. I'm going to add that to both sides of the equation and make it equal 0. So we've got a auxiliary equation of m squared plus 9 equals 0. And so m equals plus or minus 3i. So my solution is x equals a cos 3t plus b sine 3t plus nothing else needed because it equals 0 on the end there, so there's no particular integral to come through here. We were told at t equals 0, we need to differentiate it as well, don't know, so let's find out the velocity as well. So when I differentiate this, dx by dt is minus 3a sine 3t plus 3b cos 3t, and we were told that at t equals 0, x equals 2 and dx by dt equals 3. So I've got simultaneous equations coming through. 2, well, hardly. 2 equals t is 0, so that bit's 0, that bit's 1, so simply a is equal to 2. And then when t equals 0 here, so this bit's 0, so we got 3 equals 3b, and so b is equal to 1. A is 2 and b is 1. X is equal to 2 cos 3t plus sine 3t. So there's part B done. And part C, determine the maximum distance from this. So this is when we can use the harmonic form of that. Trying to remember all those bits there that we're going to go for. This is going to be cos 3t plus alpha. It's going to be minus, isn't it, to get the sign right? And expanding that gives you cos 3t cos alpha plus sine 3t sine alpha. The plus is matched this time here, so we have we need an r in front of it as well, don't we? R. So we have r cos alpha equals 2 and r sine alpha equals 1. That tells me r is root 5 and alpha is the inverse tan of a half. Inverse tan of a half is 1.1. No, not 1 point. So alpha equals 0.464. And so we've got x is equal to root 5 the cos of 3t plus 0.464. I've just noticed in the solutions they did it as a sine, but we could do it either way around. So the maximum this could ever be is root 5. So the maximum distance is equal to root 5.